Welcome everybody to the Intelsat Space STEM Awards for 2023. And what we've done is we combined two sessions, the group presentations, as well as the awards ceremony. So here is our agenda. What we're going to be doing is we're going to start with Hans Geldenhuys with a short keynote address from Intelsat. Then we'll go through just a brief background on the program that we covered for 2023. We'll have 4 group presentations, and then we will go into the Space STEM Awards, and we'll have some closing remarks. And so, Hans, may I hand over to you, please?
Yeah, thanks, Judy. And just want to do a short introduction. I'm Hans Geldenhuys. I'm the director for Intelsat in Africa. And I can't tell you how fortunate I am to, do this, intro to this very remarkable event. I really want to welcome everybody, distinguished guests, and more importantly, the brilliant young minds gathered here today. It's my pleasure, as I said, and I'm standing proud here before you as we celebrate this remarkable achievement of Intelsat STEM program in Africa. We've done this for a couple of years, and we've now seen this grow quite extensively. And seeing how this year as every year is different, and how everybody has adapted to the program this year is really remarkable. So, as the sponsor of this initiative, Intelsat recognizes the immense importance of investing into the future of our continent, and we are honored to be part of this transformative journey. STEM education is at a cornerstone of progress and innovation. And it really equips the young minds with the skills and the knowledge that is necessary to tackle the complex challenges of our times, and specifically with an industry that Intelsat is operating in. Through the Intelsat STEM program in Africa, we have witnessed now the incredible potential that lies within the young workforce and people that is adapting to what is really out there from a STEM perspective. We have seen their passion for science, technology, engineering, and mathematics ignite, and as they explore new frontiers and push the boundaries of what is possible. Intelsat, as pioneers of the satellite market, really understands this transformative power of technology. Satellites have always revolutionized communication, connectivity, and all access, and bridging the gaps to connect communities across vast distances. So by supporting a STEM program and education in Africa, we are investing into the future of our industry. So it's natural for us to look at opportunities like this. So nurturing the talent that will drive innovation and shape the satellite technologies of tomorrow is really important for Intelsat. So today, as we celebrate your accomplishments, we must really acknowledge the collective effort that was made by the program to really become a success. And through the successful partnership with MaxIQ Space, we are able to create an environment where young Africans can thrive and excel in the STEM fields. So to the young minds we will be recognizing today, I want to really extend my heartfelt congratulations. Your dedication, hard work, and passion have set you apart, and you are shining examples of what can be achieved when talent is nurtured and supported. So as we look to the future, Intelsat will continue to invest in STEM education and leverage the expertise of MaxIQ Space to provide the resources and the support what is necessary for young Africans to excel. So together we are building a future where every young person has the opportunity to thrive and contribute to the advancement of our continent. And I also want to say, together, let us continue to inspire, empower, and uplift the next generation of African leaders in science, technology, engineering, and mathematics. Again, thank you for your dedication to this program, and congratulations to all the young achievers of the Intelsat Space STEM program today.
Hans, thank you so much for those wonderful words. And yes, thank you so much to yourself and the team at Intelsat for the ongoing support of this program across the continent. When I was going through some of the assignments, and when all of us were grading the mega assignment contributions, we actually commented to each other as facilitators that how every single year the bar is raised, and that's just an indication of how we get more and more applications every year, and the standards are higher and higher. So yes, thank you once again for your support on this program as it gets better every year. So that is the challenge that we have for ourselves as facilitators, is we have to make sure that we keep it up to date and keep it going.
And again, also feel that the bar is being raised every year. I made note of that, and I want to thank you and your team as well for your dedication and what you spend into making sure that this program is success with all the young learners.
So a little bit of background. What we have is we have an application interview and screening process. And what we found was that in previous years, perhaps we wanted to improve it. And so we improve it every single year. So what we did is that this year we had a more difficult and a more rigorous initial form that needed to be completed. And from that, we had 321 successful applicants. And then for the first time this year, what we did is that we actually gave every one of those 321 applicants an assignment to complete that related to Sustainable Development Goal and number 3. And that goal relates to good health and well-being. So what it was is that there was an assignment where it required putting together comfort level charts in terms of temperature and humidity where we are comfortable, and from that we selected 30 successful participants. And so we had 30 people beginning the program. Everybody received their Space STEM kit. We were able to distribute them across the continent, and that was supported with virtual workshops on Saturdays from the various facilitators. We had individual experiments and assignments and group projects. And another thing that we introduced this year is we have a Discord server where we can handle questions and answers and collaboration from everybody around the world who has a MaxIQ kit. So we found that there was great participation from a number of the Intelsat supported candidates in terms of Discord. So the program, what we do is we cover Earth in the context of our solar system. We look at space and sustainability and how that combines. So every topic that we cover, we have a look at how do we apply that in space. And then what we also do is we have a look at which Sustainable Development Goal does that relate to. So for example, one of the experiments, which is a slightly longitudinal experiment, was having a look at the impact of natural light intensity and soil moisture and humidity, air humidity on plant growth. And then it was to have a look at how do we take those factors, collect the data, analyze the data, and how does that relate to a Sustainable Development Goal? It could relate to goal number 2, which is zero hunger. It could relate to good health and well-being in terms of a good diet with a vegetable-rich diet. But then what we did is we said, great, so we've learned that of what we need in terms of the conditions of growing food on Earth. How are we going to translate that to growing food on our spaceship as we're traveling to Mars, which is going to take us 2 years? Or how are we going to grow food in our Martian habitat? So everything related, Earth in the context of our solar system, as well as space and sustainability. So yes, everybody received their STEM kit. Here's an example of one of the STEM kits, and a full Canvas course. Canvas is a learning management system. It's the most popular global learning management system. So we implemented that, and everybody was able to engage with content and submit their experiments and their reports, etc. on Canvas. We have an Internet of Things dashboard, which we run on Kibana, and also, as I mentioned, the Discord support. And yes, our facilitators, once again, we were assisted by Colin Mamdou. Colin is very passionate in terms of supporting youngsters in space STEM. Colin is a senior executive at Vodacom. I have to say, we are experiencing a power outage at the moment where I'm sitting. And thanks to Vodacom, I'm still connected. Then we have Brittany Bull. And Brittany here in the top right-hand corner. We met Brittany when she was 15 years old. She was a participant on one of our space STEM programs then when she was still at school. She's now studying at university, and she delivered some of the workshops as a facilitator herself. But what she also was, she was a great steward and shepherd for everybody through the program, giving a lot of support and coordination on the program. We have Nico Lowe, and Nico is an Internet of Things specialist. He is a project manager, really specializing in electronics and IoT projects. And so Nico has joined us for the third year as a facilitator. And unfortunately, we don't have a photograph of Milena Ivanova. And Milena is a very passionate teacher, originally a meteorologist as her first qualification, and she's based in Gauteng. So Milena has delivered really some compelling workshops in terms of climate action, climate change, how what we do on our planet, how does that actually affect our living conditions on the planet. So yes, from a group assignments perspective, the brief for the group assignments was to develop a sub 5-minute presentation on a design concept for a satellite that would support one of the Sustainable Development Goals. And so all of the groups came through with their assignments. And what we decided earlier this week was that what we would do is we would actually have each group pre-record a video. Let us start with Sustainable Development Goal number 11, which is sustainable cities and communities.
It is estimated that by 2050, 7 out of 10 people will likely live in urban areas. In short, Goal 11 aims to make cities or human settlements inclusive, safe, resilient, and sustainable. Inclusive cities prioritize equal access to services, opportunities, and resources for all individuals. Satellite technology can play a crucial role in bridging the digital divide by providing internet connectivity to underserved areas. Satellite-based internet services can ensure that all residents, regardless of their location, have access to online resources, education, employment opportunities, and digital services, thereby promoting inclusivity. Safe cities are those where individuals can live, work, and thrive without the fear of violence, crime, or any other threats. Satellites are ideal for surveillance and monitoring, with high-resolution sensors helping to detect and prevent crime, and be a valuable tool for emergency response and disaster management. Resilient cities are those that have the capacity to anticipate, absorb, adapt, and recover from shocks and stresses such as natural disasters, climate change, and socioeconomic disruptions. Climate change monitoring data can help us enhance early warning systems to mitigate disasters by being prepared and responding effectively. To ensure long-term sustainability, we need to focus on reducing and recycling waste, using clean energy, making systems as efficient as possible, and changing behavior. Extreme examples of the circular economy is the Ocean project, where sailors work with coastal communities to turn plastic trash into new products. Plastic is smelted and 3D printed. Communities can turn beach trash into items they can sell. Ocean, of course, needs internet connectivity to spread the message, and they are reliant on satellite internet, as well as GPS to navigate. On a bigger scale, Fulcrum Bioenergy is converting trash into jet fuel. It cannot yet replace fossil fuels, but scaling up this abundant, low-cost resource is a promising step to a greener future. And of course, planes need GPS to navigate, plus the demand for internet on board is growing rapidly. Blue Shift Aerospace have been a pioneer in developing the world's first commercial rocket, powered by carbon-neutral biofuel. The fuel is so safe you can actually eat it. Have a look at the video link to see how Blue Shift CEO takes a bite of the rocket fuel. A truly Earth-friendly way to get to space. Earlier this year, scientists completed the first transmission of energy from space to Earth. Through the Space-Based Solar Power Project, researchers are working to deploy a constellation of modular spacecraft that collects sunlight, transforms it into electricity, then wirelessly transmit that electricity wherever it is needed. Satellites can provide high-resolution imagery and data to optimize urban planning and systems. Remote sensing can monitor air quality, water resources, and vegetation health. It can also aid in disaster preparedness and response, enhancing overall resilience and minimizing the loss of life and property, or even ensuring equitable access to clean water for all residents. Changing people's behaviors and increasing awareness are key factors in creating a more sustainable and greener future. By fostering a shift in mindset, individuals can become conscious of their daily choices and the impact those choices have on the environment. The collective impact of small actions can be the ripple that builds into a wave, and it starts with us. Thank you.
Did you know that in the year 2023, the concentration of carbon dioxide gas in the atmosphere has been at the highest level it has ever reached, which is 420 parts per million? My name is Amelia Kister, a member of the SDG 13 Climate Action Group, and on behalf of my group members Munotida Mantiziba and our mentor Brittany Bull, I would like to welcome you guys to our project on climate action. Greenhouse gas emissions, including carbon dioxide, nitrous oxides, chlorofluorocarbons, and methane gases, have increased since the pre-industrial era due to the increase in population and economic growth. This has led to climate change due to the increased emissions by the increased population through the industries and objects like cars. This has also led to the depletion of the ozone layer, specifically by the chlorofluorocarbons. Climate change has led to global warming, which has led to changing weather patterns and disrupted the usual balance of nature. It has also led to desertification in different areas, making it difficult to grow food due to lack of rain. Some of the effects of climate change include hotter temperatures due to global warming, severe droughts also due to global warming, which leads to an increase in evaporation rate, thus leading to dry soils, and inadequate moisture in the soils leads to lower plant growth, thus leading to inadequate food. We are tackling this challenge by designing a payload for a satellite to monitor pollution in the atmosphere, by detecting various gaseous pollutants, which are these greenhouse gases mostly, and using the data to determine the main sources of these emissions, and putting across the proper control measures in these locations. By identifying the main sources of pollution, pollution as a factor contributing to climate change can be reduced, and the climate change can be controlled to a certain extent by putting in place control measures to reduce these emissions, especially in the areas where they are concentrated. Urgent action is required at all levels of society to limit global warming and minimize the worst impacts of climate change. Dependence on fossil fuels due to them being abundant and easily accessible, lack of global cooperation among countries, and inadequate public awareness on climate change causes and its effects. The Paris Agreement, also known as the Paris Climate Accord, is an international treaty aimed at addressing climate change and reducing greenhouse gas emissions, first adopted on December 12, 2015.
Hi there, I'm Munotida Mantiziba. Methane and carbon dioxide are both greenhouse gases which trap heat in the atmosphere, leading to global warming. The primary sources of carbon dioxide emissions are associated with burning of fossil fuels, deforestation, and land use changes such as deforestation for agriculture. Therefore, people should shift towards renewable energy and sustainable land management. The satellite description. The use of satellite imagery provides more accurate data than traditional ground-based monitoring. The satellites will be equipped with various spectrometers. The data will then be used to determine the areas where the emissions are concentrated. Once these areas have been determined, proper control measures will be put across. Other topics of research we identified yet could not cover in this project. Using the satellites to track indicators of global air pollution and climate impacts, detection and monitoring of marine pollution using satellites, and using satellites to track areas where desertification and land degradation is most rampant by tracking the vegetation cover. With this, we thank you.
Sustainable Development Goal 7 is to ensure access to affordable, reliable, sustainable, and modern energy for all. SDG 7 focuses on ensuring access to clean, affordable, and renewable energy that is reliable and sustainable, and providing this energy for people across all socioeconomic groups. The biggest challenges in achieving this SDG is the continued use of fossil fuels and the lack of access to clean electricity for developing countries. Low accessibility to improved energy technology is attributed to the interrelated socio-economic, cultural, and technical factors. Without breaking these barriers and having better integrated economic and social policies, achieving this goal cannot be possible. Many individuals in developing countries, especially in the rural areas, use fossil fuels as a form of cooking fuel. The continued burning of fossil fuels such as coal has led to increased emissions of greenhouse gases that negatively impact the environment, polluting the atmosphere, causing climate change by trapping heat. How do we achieve SDG 7 for all people? Providing renewable clean energy to rural communities requires a multifaceted approach. One solution is the expansion of decentralized renewable energy systems, such as mini-grids and off-grid solutions. Mini-grids, which are localized electricity generation and distribution systems, can be established in rural areas, utilizing renewable energy sources like solar, wind, or hydropower. These systems can provide reliable electricity access to households, schools, healthcare facilities, and small businesses. Off-grid solutions, including solar house systems and portable solar lanterns, offer affordable and sustainable lighting and basic electricity services for individual households. A UV ray detector deployed on a satellite can play a crucial role in achieving Sustainable Development Goal 7 by supporting efforts to monitor and assess solar energy potential, promote renewable energy adoption, and ensure sustainable energy practices. The detector can gather valuable data on UV radiation levels, which are essential for accurately estimating solar energy potential in different regions. This information can guide the planning and implementation of solar energy projects, helping to optimize their efficiency and output. By identifying areas with high solar irradiation, decision makers can prioritize the deployment of solar infrastructure and facilitate the transition to clean energy sources. Moreover, the UV ray detector on a satellite can assist in assessing the performance and maintenance needs of existing solar installations, enabling proactive measures to optimize energy production and ensure long-term sustainability. The job performed by my satellite, which would be performing UV ray detection and monitoring for SDG 7, would be that of a remote sensing satellite or a solar monitoring satellite. Its primary purpose would be to collect data on UV radiation levels from space using specialized instruments and sensors. This satellite would be equipped with a UV ray detector and other relevant instruments to measure and monitor UV radiation patterns across different regions of the Earth. By orbiting the Earth and capturing data from space, the satellite can provide comprehensive coverage and insights into solar energy potential, climate change impacts, and support sustainable energy planning and implementation. The satellite would gather precise data on UV radiation levels across various geographical locations and over time. This information helps estimate solar energy potential, enabling the identification of areas with high solar irradiation for the deployment of solar energy infrastructure. By monitoring UV radiation, the satellite can provide insights into climate change-related phenomena, such as ozone layer depletion and increased UV exposure. This information is crucial for understanding environmental changes, assessing the impact on ecosystems, and formulating strategies to mitigate harmful effects. The satellite can evaluate the performance and efficiency of existing solar installations. By monitoring UV radiation levels over specific regions, it helps assess the output of solar energy systems, identify areas for improvement, and optimize energy production. By evaluating solar installation performance, the satellite can optimize energy generation from solar panels, thereby increasing the adoption of renewable energy sources and reducing reliance on fossil fuels. Monitoring climate change impacts from space allows for better understanding and tracking of environmental changes. Accurate data on UV radiation levels can be utilized to optimize solar panel placement and angle, improving energy efficiency and maximizing electricity generation. In conclusion, the deployment of a satellite equipped to obtain crucial data on UV radiation levels, climate change impacts, and solar installation performance is a significant step towards achieving SDG 7, ensuring access to affordable, reliable, sustainable, and modern energy for all.
Sustainable Development Goal number 3. Let's have a general overview of our project. A brief explanation of what our satellite will be doing. We want to combat malnutrition and food insecurity in developing countries, because that's mainly caused by lack of early warning for areas at risk of food shortage or nutrient deficiencies. And this will be achieved through making this satellite payload that monitors crop health and predict yields using multispectral imaging. This will come to our results, which will give us an early warning system about crop health and hence improving and preventing the malnutrition and food insecurity and achieving a key factor in maintaining good health and well-being. Let's get to understand better the concept of multispectral imaging in agriculture. Multispectral imaging is a technique that uses multispectral sensor for collecting data from multiple wavelengths in form of images. It collects data in many and multiple wavelength bands. This enables it and gives it the capacity for seeing what we can't see with our human eyes. Every crop reflects different amount of light, which gives the multispectral imaging a capacity to uniquely identify each crop. On the previous slide, we saw that each crop reflects a certain amount of light, which makes it to differ from other crops. So let's see what those different wavelengths being reflected by the crop and what they can detect. Normally, blue light indicates the plant photosynthetic activity. Green light is the measure of the amount of leaf surface area per unit of ground. Red light indicates the water content of the leaves. Near infrared light can be used to measure the biomass of the plant as well as the water content of the leaves. In summary, uses of multispectral imaging in agriculture includes crop identification, crop health monitoring, yield prediction, fertilizer and irrigation management. Now, let's put multispectral imaging into action by building a satellite. Here we're going to see our satellite payload design. This satellite will be using multispectral imaging for monitoring crop health, crops which are enough. What does our satellite will be made of? Here is a list of many instruments that will be needed in our satellite. The main component is a multispectral sensor. It will collect in multiple wavelength bands the image of crops on Earth. A data acquisition system will be used as a storage of data that is being collected by a multispectral sensor. A data processing system, this will be for processing the data that is being stored for a meaningful information. A communication system and the communication system for transmitting this information to Earth. Also, there are other tools which will be needed for our satellite to function. Solar panels as a source of energy, batteries for the storage of energy, computers as processors, heat shield for preventing heat, antennas for getting a connection with the earth, and finally radios as a means of communication. Overall, our satellite is supporting the Sustainable Development Goal number 3, specifically Target 3D, which states strengthen the capacity of all countries, in particular developing countries, for early warning, risk reduction, and management of national and global health risks.
Best unboxing video came from Natalie, and we had a number of runners up. This year, what we did is the very first assignment that everybody completed once they received their kits was to develop an unboxing video. So Natalie, well done. Really terrific video, and we really need to give recognition to everybody else who submitted their unboxing videos. And the next award is for the highest average assignment grade, and that goes to Lucide. So there was 15 assignments or projects all in all, one relating to every topic. So what we did is we had a look at those average grades. There's also another thing that I'd like to say about Lucide is that she managed to submit every single project and assignment on time before the deadline. There were a number of circumstances where we needed to extend the deadline because some people were writing exams or they had to go on trips, etc. But Lucide, she really came in and she submitted every single one of those before the deadline. Then the next award goes to the most responsive. And as I mentioned, Lucide had actually submitted everything by the deadline to Daisha. He also submitted absolutely every single assignment and report, and was very responsive in terms of giving feedback. So what we want to do is we want to extend that award to him as well. As most punctual and engaged was Ernest. Here's a great photo that Ernest has sent through with him with his kit and his Intelsat and MaxIQ STEM program t-shirt. Yeah, every single time one of the sessions started, Ernest was there, he was early, he was very responsive to ask questions and to engage the facilitators, which was really terrific. And best mega assignment came from Eileen. And the mega assignment topic was a sub 5-minute video on design considerations for building a habitat on Mars. Really very interesting concepts that came through, a lot of research that went into these mega assignments. The results came in, and Bianca was able to analyze those. And the winning group was for Sustainable Development Goal number 11, the first presentation that we had today, delivered by Eileen. So well done. It was all very close. And so Bianca, thank you very much for that. And congratulations to Eileen and the team for that wonderful, wonderful group presentation. And to close out for today, we have a special announcement and a nice surprise announcement. Intelsat has proposed that what we do is we start developing an alumni, and of the participants from previous years in the Intelsat Space STEM program. This was the 3rd year that we delivered the program, and so this is the 3rd cohort that we have. And what we do is that this was mission 1 that everybody completed. There are some participants who are going to go on to a mission 2, which is always definitely much more space related. And then one day when one of our launch providers is able to get to space. We'll have a mission 3 when we go to space. And but what we're doing, certainly in the meantime, is putting together an alumni. Emmanuel Albert from the first year cohort, he has volunteered to facilitate and really and pull together the alumni and make sure that we have a wonderful collaboration with the group. And for those joining the alumni, everybody will receive a tiny GS ground station kit, so that we can all actually have our ground stations across the African continent and start downloading a student satellite data and contributing that to the community and research satellites, all of that kind of thing. So with that, I would like us to conclude. And once again, to everybody, Hans, to yourself and the team at Intelsat, thank you once again for sponsoring this great program. And Christelle, thank you very much for your very kind words in the chats to everybody. Very encouraging, thank you. And I'd also like to have a special call out. I saw Andreas was here earlier. Maybe he had to rush off to a meeting. Andreas actually, many years ago, he linked with me on LinkedIn and said, I believe there's something we can do here. And he introduced me to Christelle. And then during the height of the pandemic, Christelle then came forward with this idea of why don't we actually deliver a program using virtual technology and everybody getting their kit at home. So, so yes, that is how it's all come about. And I'd also really like to recognize Peter Burden. We met Peter a number of years ago when he headed up the BBC desk for Africa. And Peter has become a very strong friend of MaxIQ Space and all of our nonprofit work that we do across the continent. So Peter, thank you so much for all of your support, also for joining us in the session and the wonderful support that you give to all of our youngsters across the continent. And with that, Hans, I'd like to hand over to you for some closing words, if you don't mind.
Thanks, Judy. Yeah, again, just the final word of saying congratulations to everybody. It's really a proud moment if you've achieved something like this. And, you know, with us knowing what the industry looked like on the other side, you know, I can tell you guys are really venturing into a really interesting space. You know, staying in STEM education, it will definitely open up so many opportunities for you. And it's really an industry, specifically satellite that I'm referring to now. You know, besides the interesting science aspect of it, you know, there's also this human aspect of it, like I alluded towards earlier, where we're really connecting unconnected people and, you know, seeing how that has an impact on the social aspects, economic aspects of not just the country, but also the people and how they could create, you know, mini industries and you know, selling of, you know, various aspects. And I'm thinking about some stuff that I've seen with my own eyes and areas in Africa where we've managed to connect areas which was never connected. Just seeing how that lighten up, you know, communities is really, really something that warms the heart. And I really want to, you know, encourage you all to stay in so dedicated, stay so committed to, you know, to delivering on, you know, your education planning and ideals. And I'm sure you'll be richly rewarded on that. And thank you, Judy, to you and your team for creating a platform for us to support, and then also to create an environment for these students to, you know, to further their education.